Hello, Legacy Savers. Today we're going to look at graphing parabolas in Vertex or Intercept Form. What's your learning objective for today? I can graph a quadratic function when it is in Vertex form, and I can graph a quadratic function when it is in Intercept form. So we've graphed in standard form already. This y equals ax squared plus bx plus c, using that vertex negative b over 2a, right? Well, what we're going to do is vertex form first. So, do you remember how our absolute value graph shifted amount? So, if I had the graph y equals absolute value of x plus 2, remember that made it go, up 2? Well, if you have a plus 2 on the back end, that's the same thing. It's still just going to go up 2. Same thing here. This would have been down 4, right? Because it was on the outside. Well, this is just down 2 because it's on the outside. Remember, when we went inside the brackets, or inside the absolute value bars, it changed the way we thought. So instead of going to the left, we went to the right when there was a negative. Same thing when you have parentheses. It's just going to go right 5. Same thing here. Left 5. Well, this is left 5 as well. So the transformations that were happening still happened as well. Remember, this gave us a v that looked like this, right? It flipped it. Well, this is just going to give us a u that's flipped as well. So that negative, all it does is flip it about the x-axis. So let's keep that in mind when we're thinking about how our vertex has moved. Go ahead and grab that foldable out again today. We're going to fill in the properties of vertex form. So very first thing, let's write the vertex form. F of x equals a times parentheses x minus h squared plus k. First things first. H represents the horizontal shift, how far left or right from the graph that shifted from 0. Okay? K is representing the vertical shift. How far up or down did you go from 0? Your vertex is hk. So that's going to be our way to find our vertex, is thinking, how did this shift? How would this move? So let's try an example of that. I have 1/2 x minus 3 squared minus 5. Now, let's think how this would move. Minus 3, remember, inside the absolute value bars was opposite of what we thought it should be. So instead of being left, we would have gone right 3, right? This would have told us to go down 5. So let's actually start at 0, 0 and do that. Let's go right 3, down 5. That is your vertex. So that's going to go in the middle here. So right 3, down 5. And I'm going to fill in my vertex thing right there. So now, just like standard form, you're going to put some numbers around that. And we're going to plug them in. So 1/2, 1 minus 3 squared minus 5. Well, 1 minus 3 squared is negative. 1 minus 3 is negative 2. Square that. That is 4. Half of 4, well, that's just 2. And 2 minus 5, well, negative 3 looks like it. Let's try this. Let's plug in a 2 as well. 2 minus 3, well, that's negative 1. Square that, that's just 1. Times 1/2, that is a half. Minus 5, negative 4.5, right? Or negative 4.5. Already got my 3. Let's do 4. 1/2, 4 minus 3, squared, minus 5. 4 minus 3, that's 1. Square that, that's 1/2. Negative 4.5. Now you're probably asking, Marsh, why are you doing all of it? Isn't it going to be the same? I do it all just in case I mess up. You've seen how bad my math skills can be sometimes. I make sure I do both sides, so I do make sure that I get the answer on both sides the same. So 2 squared is 4, 1/2 is 2, minus 5, negative 3. Let's graph those. So I got 1, negative 3 for 1 dot. Whoop, that was a little off. 2, negative 4.5. Right about there. 4, negative 4.5. And 5, negative 3. Connector. dots. There we go. Ooh, that's actually a pretty good parabola. Look at that. So it looks like he's opening up. Same thing counts for the A term. If it's a positive, it's going to be opening up. My axis is symmetry, so if I put a dotted line here, I can fold, it looks like right here, which is 3, right? So that would be x equals 3. Looks like I have a minimum value. And what's the lowest minimum value? Right here, looks like I'm hitting, that's my lowest y value, which is y equals -5. Domain, all the negative x's, right, because it's going to keep opening. All the positive x's, so it looks like my domain is -infinity to infinity. What about my range? The lowest y value I'm hitting is my min at -5. But it looks like I'm going forever up here, so I get a positive infinity, right? Increasing and decreasing intervals, well, it looks like I'm decreasing first, right? And I'm decreasing until I hit my turnaround point, or this 3 right here. So I'm decreasing from -infinity to 3. And then it looks like I start going up right here, right? Because that's where my graph goes. So from 3 to positive infinity, it looks like I'm going to be increasing. Now, what if you'd rather graph using standard form? Not sure why you would, but you might. Change from vertex form to standard form. This is what you're going to do. So I'm going to first, I have this squared here. I need to write that twice. You can't give that squared in. It is not the same thing, okay? Now, let's multiply this 1/2 in. So I'll get -1/2 x minus 4. Now, you only need to multiply it to the first one, not both. Some people like to multiply it, try to multiply it to both of these. You only need to multiply it by the first one. Now, let's FOIL. So I get -1/2 x times x. Well, that's just -1/2 x squared. -1/2 x times a positive 8 is a -4x, right? -4 times -4 times x is -4x. -4 times a positive 8 is a -32. I still have this plus 35 hanging off the back there. Let's combine our like terms. Looks like these guys are alike, and then these two are alike, right? So I still have this -1/2 x squared laying out there. -4x, well, that's just -8x. -32 plus 35 is positive 3. So I converted from what was vertex form to standard form. So any problem can be made into a standard form problem if you're willing to do the math to satisfy that. Alright, now let's write the properties of intercept form. So intercept form looks something like this. A, x minus p, x minus q. What is this? Why is it called intercept form, you're probably asking? Well, the x value of the vertex is halfway between the intercepts. And the intercepts are these p and q. Those are your x-intercepts of these graphs. So your equation for your x value of the vertex is p plus q divided by 2. Or basically, can you see the halfway point? Where is the turnaround point that would be in the middle? So those two x-intercepts are going to allow you to graph the equation only if you find the vertex. So you're only going to need 3 points for intercept form. Let's try an intercept form graph. So I have x plus 3 and x minus 1. So the very first thing you're going to want to do is come and find some x-intercepts. So basically what you're going to do is set both of the parts equal to 0, just kind of like you would have been factored, okay? So x equals -3 and x equals 1, right? Well, those are your ordered pairs. -3, 0, and 1, 0. So you have found 2 dots on your graph. Let's find the third. So basically I need to think, what would I be able to? Where would the middle of this parabola be? Because it's got to be somewhere in the middle of these two dots, right? So let's think. If I'm at -3 and 1, if I move one more in, I would be at -2 and 0, right? And then -1. -1's got to be in the middle. But now you can't just go, there's my parabola. That's not the case. You need to find that y value for that -1. So how are we going to do that? Just like we've been finding it before. We're going to plug it into our equation here. Like that. -1 plus 3, well, that's 2. So let's put a little 2 above that. -1 times -1, well, that's -2. So 2 times -2 is -4. So I can graph that now. 1, -4. And then you're going to make a nice round parabola. There we go. Look at my parabola, and now we can answer our questions. Opens up. My vertex, we found it. It's in the middle here. -1, -4. Yeah, it's a really bad one. X-axis of symmetry. Could fold it right here. That looks like it's x equals -1. Looks like I have a minimum value. The lowest y value I hit at is -4. So y equals -4. My domain, -infinity. So I'm covering all the negative x's, right? Couldn't close the flap on our domain foldable, if you remember that guy. Can't close that flap, so it looks like I'm going from -infinity to a positive infinity. Range, lowest y value, -4. But it looks like I'm covering all the positive y's, so I'm going to infinity. Let's look at our increasing and decreasing. Well, something's got to be going on here, and something's got to be going on here, right? Because it's the turnaround points when it's going to mark my increasing and decreasing interval change. So it looks like it's going down here, right? So from -infinity to -1, I'm going downwards. And increasing, I'm going from -1 to infinity. Because my graph looks like he's going upwards. Now, what if you would rather graph using standard form? Personally, I'd graph using Intercept Form. But, to each their own. So, what you can do is distribute that 3 in first. So I'll get 3x minus 12. But you're not going to distribute to the x plus 6. Kind of like we didn't distribute that 1/2 before. You just get to write it. You just get to distribute once. Now, let's FOIL. So I got 3x times x. Well, that's just 3x squared. 3x times 6, that is 18x. -12 times x is -12x. And -12 times 6, -72. Let's combine our like terms. So I got 3x squared plus 6x minus 72. Notice my a value is the same on both, so that still tells you, are you going up? Is your parabola going up, or is your parabola going down? That allows us to be able to see it a little quicker. And that's the end of this video. See you later, Sabers.